I'll talk about it later. All right, let's revise where we're up to now. So today we're going to finish the chapter 5-1, which is the reactions of the organic acid and bases. This is the kind of final of all that chemical reactions you need to memorize. So let's start from what we learned about the reactions. So give us some summary of the chemical reactions that we're learning through, and then you need to memorize several things. For the chemical reactions, for the organic chemical reactions, the things that you have to memorize: one, you need to memorize the name of the reaction. If you know the name, like for example, hydration, dehydration, halogenations, hydrohalogenations. If you know the name, you need to know the name of that, and you also need to require the reactants. You also need to require the conditions, including that if there is any catalyst, you need to know the catalyst as well too. Four, of course, you need to know the its products, and these, and plus sometimes the byproducts, something that comes after that product too. So these are all the typical things, and you should be able to draw in both of the condensed and structural formula for all the chemical reactions as well too. So going through some of the chemical reactions, I need to put the alcohol in the middle. Alcohol. We can divide the chemical reactions into two parts. One part is about how we producing the alcohols and which from, and second part is how we use those alcohol and reactions of the relevant alcohol reactions too. So let's start from that. Alcohol can be produced from the functional group called the alkene, which is the double bond, and the process of producing the alcohol, alkene to the alcohol, is named as the hydration. Okay, so what do we need to hydrate the alkenes? What conditions do we need? Diluted the acid. So it's either be we tend to use H2SO4, the phosphoric acid. We also need some heat. So this is what I mean by you need the factors you need to know for everything. You need to know what reactants we use to produce what products, the name of the reactions, and the reagents or the conditions for that. What if you're going backwards? Haley, from the alcohol to the alkenes, what if we need to go backwards? We did that last week. From alcohol to alkene. It's called dehydration. What do we need for the dehydration? Concentrated H2SO4. And maybe it's a bit of a heat as well too, but just leave that for the heat for now. This is the condition. So, and the way you can remember the reactions are now, one is using diluted, which requires more water, hydrating it. The one without eliminating the water requires the concentrated H2SO4. This is one method. You can memorize that. Okay. We have another hydration method, another hydrations from here to there. We also use the dilute, not the dilute H2SO4. In this case, we use the water H2O with some catalyst. The catalyst can be varied. It depends what type of the alkenes you have. This is the second of the hydration as well too, with the different reagents we're using. Okay, now, Hannah, what would be another method to produce the alcohol? You should have the flow chart that I gave you last week. I mean, it's all there. The one that I drew that on the board last week too. Yes, Rachel? Yeah. Another method to produce the alcohol? No, that's the reaction to alcohol. Substitution of? Thank you. So we have the haloalkane over here, it goes to this reaction using the substitution with strong base. With the strong base, so for example, like sodium hydroxide or the potassium hydroxide is the agents we're using to make a substituting that. Is there any way we can going back from alcohol to the haloalkane? Like this? Yes, this is another substitution too. Substitutions. In the case of that we're using for the alcohol, we are adding some HX, which is the halogen halide, or the anything like example HI or HBr. And we talked about like, which one has the faster reactions in the periodic tables too. As it's going down. There's something actually that comes out in the HSC recently now. We're going backwards. The iodide tends to carry the fastest reaction rate, and the slowest by the fluorine there too. Something we discussed last week. Okay, Steph, any other method to produce the alcohol? Production of the alcohol? You don't remember, Victoria? If you don't memorize these chemical reactions by this coming holiday, you'll be in trouble. Not from me. You actually be in trouble because there'll be no time to memorize the chemical reaction after this holiday. Make sure you revise it, memorize everything by this holiday because you have no assessment anymore. Okay. So there is the glucose, and we're going through the reaction called the fermentation. Okay, fermentation is a limitation that this only be like this is the ethanol only. You only produce the ethanol from the glucose, not like some other like alcohols too. I ask you to memorize some of the conditions and catalysts we use for the using for the fermentations. One is that we need to have the yeast. Needs to be in the optimal temperature of like around 35 to 37 degrees Celsius, or like human body temperatures, we tend to say that. It needs to be an anaerobic. Means that there's no oxygen required, and there should be no oxygens. 4, it should be the aqueous. That you kind of put some water into that too. So glucose tends to come in the forms of the AQ in that reason. Okay, so that's the method to produce the alcohol, some production of the alcohol too. Okay, in general, like the production of the alcohol from the glucose is more like used as a biofuels. It takes a really slow process. We tend to use the haloalkane to produce the alcohols in commercially, like in something we use in most of the alcohol we use. Okay, all right, let's talk about then the reaction between alkene to a haloalkane. Alkene to the haloalkane. Alkene is basically double bond. Haloalkane is something with the halogen, and there's only single bonds only. This is a reaction called the addition reaction, or sometimes known as addition. The reaction for this process, you need either be X2 or the HX. X2 as in like a 2 halogens attached, like a chlorine gas, Cl2, bromine, Br2. So the test we use to identify the presence of the alkene is known as the bromine water experiment. You must know the color, the change from the bromine water experiment with the bromine with alkene and alkane, and that's something you would get definitely too. So the main difference between X2 and HX, this is producing dihalogen. This is producing just the one halogen itself too. Okay, we had from alkene to another reaction to produce the alkane. So what's the reaction from alkene to the alkane? Hydrogenation. So we can name that as addition reaction. That's a very special type of the hydrogenation. Do you remember what we need for the hydrogenation? Nickel ore, PT, platinum. So we need to have the H2 with the catalyst of the nickel, Ni, or the platinum. The metal catalyst. If you remember that hydrogen itself is not strong enough to break the bond between the two double bonds. So what they do, to get the help of the nickel and the platinum, nickel and platinum is kind of working as kind of sticky tape. It's kind of holding that alkanes really strongly so that hydrogen can attack the double bonds really easily. Therefore, lowering the activation energy, maximize the yield in that case. So that's from the alkane to the alkane. And we also learned about alkanes reaction, that alkane can go to the haloalkane. This is known as the substitution reaction. And for those substitutions for the alkane, because alkane has a really strong like a bonding, so what do we need, Haley? What do we need? For the substitution of the alkane, what do we need? We need a UV light. UV light with the plus the HX or the X2. That's how we can like substituting one of the hydrogen into the halogens, therefore producing the haloalkane 2. In other words, you can think about the production of the alcohol from the alkane. This is something that we're going to discuss next week further, but you may say that from the alkane, we can produce back into the haloalkane by using the substitution reactions and then going on to alcohol reactions like that. The things that we didn't really talk about in here is the alkyne. There's not many reactions of alkynes, but there's one reaction from alkynes to alkene. Okay, this is also be hydrogenation. And in this case, it uses something known as Lindlar's catalyst. In the presence of the Lindlar's catalyst, what they do is called like it's kind of stopping the reaction at the alkene, so it's kind of stopping the further reactor to the alkane from alkynes. That's one of the reactions that we learned as well for the alkynes. And basically, this is all related to the production of the alcohol. Can you see the alcohol is in the middle? And the main thing is about how to produce the alcohols from it here. Let's talk about some of the alcohol reaction now. Alcohol, as we learned, all of those going through the combustion. So we're not going to write the combustion in this case because it's CO2 produced basically, or you can do, but going back in the photosynthesis in glucose 2, it's more about this one. We have alcohol's first reaction is the oxidation. So in a case we have primary alcohol oxidation. Okay, we also have the secondary alcohol oxidation. Need a bit of bigger arrow for that. Hannah, what do we need for the oxidation? We need something called acidified permanganate, or the dichromate. In a form, you can write it as H plus Cr2O7 minus, or H plus MnO4 minus. This is how you can write in the chemical reaction type. For the primary alcohol oxidations, as a result of the oxidation of the primary alcohol, for example, ethanol, it's producing into the aldehyde. It can further react into the oxidation of that aldehyde. You can further oxidize into, so oxidation again. And this shares the same reactant, so it's basically H plus Cr2O7 minus as one example. You can use the permanganate, by the way. It doesn't really matter. It's either be 1 or 2. And this requires a bit of the heat. If you remember the video we watched last week, that they used the system called the reflux, gently, gradually heating up the systems, and finally getting the product called the carboxylic acid. Okay, Now, for the secondary oxidation process there, okay, it will have going through the same, using the same catalyst called the acidified permanganate or the dichromate. We actually, the actual chemical we use is a potassium dichromate, potassium permanganate in general too. And as a result of the secondary alcohol oxidation, it will be ketone. It's the one that we now finally get. Okay, we talked about the dehydration process and the substitution back into the haloalkane. That's one of the reactions, two of the reactions we learned last week as well. Another reaction that is related to today's class is the reaction of the carboxylic acid with the alcohols. So how did they come? They would come like this. We're going to combine carboxylic acid and alcohols together and producing the functional group called the ester. That process of producing the ester is known as, title have the esterification. And for this process, it is required that you need to have a few agents. One, it must be in the reflux system, used like in a condenser, as we watched the video. I showed on the video for today, and you will do this experiment in the schools, it's 100%. You also need to have in the concentrated H2SO4 is required for this process. And those two are the some conditions required for the esterification in general too. So what we do is we mix the alcohol and carboxylic acid with the presence of the concentrated H2SO4 and put it into the reflux systems. You finally get something known as the ester. The ester look like this in terms of their functional groups. The O to the R1 to the R2. And I described that this is the body and that's the tail of that. So we're going to go through some of the naming of the esters today as well. Okay, carboxylic acid can also go through a further reaction. Let's relate to some of the reactions that we need to learn today. This can go for these reactions with, write it down, like this, and this is called the substitution reaction. And using that agent known as H and R. And this is producing the amide groups. Amide, if you remember that, it looked like this with a carbonyl with the NH or NR. It's kind of attached, or NR2 I should say. It depends on the what they have. Okay, so we're going to go through this on the reaction of the this amide as well as the part of the chapter 5 today. Any questions about these reactions? Guys, this is something that you need to practice by yourself. And you should be able to draw this kind of flow chart by end of this coming holiday. So if you're not too sure about how to memorize that, do this. Don't just write it down, narrate all the reactions, try to memorize that. You're just basically wasting your time. This is the best method to memorize the A to Z of the chemical reaction used in the year 12. Okay, draw that like 10 times a minute. Hannah, draw that 10 times. Yeah, and I will see that in the end of the term 1 exam, the module 7 test, whether you memorize it or not. Or for next week too, we got to do some questions related. Any questions about the graph? Any questions about flow chart? Acidified permanganate and dichromate, which is known as that. All good?